Thank you so much. Let's start. Okay, so let me reset my things. So today we are going to time travel from the 80s, 8-bit world, straight into .NET 9. My name is Alexandre Mutel, and I'm VP Engineering at Data Galaxy, working in data governance. And in my spare time, I love contributing to open source projects in the .NET ecosystem. Some of them became popular, but most of them are pretty niche, but I like them. And above all, I'm a .NET performance enthusiast. So today, I'm going to talk about this project, what made the 8-bit era so magical, and why the Commodore 64 in particular. Then I will introduce the .NET SDK I've built for it, like the retro C64 SDK, with hopefully an entertaining live demo. I hope that things will all work. And if time allows, I'll wrap up with a look at the architecture and what's coming next. So the very first computer I ever touched was a Texas Instrument TI 9948. I didn't own it. It was at my uncle's place. But later, I was lucky enough to get my own Amstrad CPC 464. And then my beloved Amiga 500. I had a nice retro red tracksuit at that time. And one of the magical things about the 8-bit era was that you could jump straight into coding right there from the machine itself. And you would start coding with BASIC. Sometimes you could move on to assembly language. Or, of course, you could just play games. And it was a pure moment of creativity, and I love doing both. I still love doing both. So back then, there was so many different 8-bit machines, each with its own charm and quirks. So why did I choose the Commodore 64 for this experiment? And the reason is quite simple. Actually, the Commodore 64 is actually coming back thanks to Perry Fratic. Is a well-known YouTuber in the retro computing scene. And he bought the Commodore brand just a few months ago, in the middle of the year, like in July. And he brought together the community to design a brand new machine that is fully compatible with the original Commodore 64, but built with new hardware. So I ordered one, and it's called the Commodore 64 Ultimate. And while waiting, I thought it was the perfect opportunity to start learning about the Commodore 64 and see what I could do already with it. So I'm going to receive it this month. So I'm super excited to try also some of my code that I prepare for this presentation and try it on real hardware at the end of the year. So let's take a look at what's inside the Commodore 64. At its heart, there is the 6510 CPU, and it's running at about 1 megahertz, and it depends on PAL and TSC stuff. Then you have the VIC-2 graphics chip, which is responsible for all graphics, color, sprites, smooth scrolling, and things like that. There is the C chip, which is the sound synthesizer of the 664, and it's amazing. It's very popular for its legendary music. 2 CIA chips for I/O with the disk drive, external disk drive, for example. And of course, the system had a whole 64 kilobytes of RAM and 24 kilobytes of ROM. So you are wondering, how can we access 64 kilobytes plus 20 kilobytes of ROM? So if we look at how memory is organized in the Commodore 64, the address space is 64 kilobytes. But it's not all RAM by default, because the system maps part of the space to ROM. And there is a basic interpreter, I/O register for communicating with the coprocessors, and the kernel, not the kernel, but the kernel, which acts as a kind of like a built-in operating system layer. And if we look at the very bottom of the RAM, we find two important areas, the 0 page and the stack. The 0 page is special because it's 256 bytes of memory. It's a page. And many instructions can access it with shorter opcodes, so which makes them running faster, and it's smaller. So it's used for optimizing programs. And then there is the stack, which is another page of memory just above. And it's interesting as well, like compared to our modern computers, because it wraps around automatically when you pull data. If it goes back at the bottom or the top, it will come back at the top or the bottom. So it's a ring stack. And finally, if we zoom in even more, there are two tiny registers, 0 and 1, and the 1 register, it's what makes the memory layout possible, because by just flipping these few bits here, you can switch between showing the ROM or accessing the underlying RAM entirely. So when programming the 64, usually these days you program it from a PC. And some people are very brave and program it from the machine itself, a real machine. So I'm not that lucky. And so usually people are writing assembly code in a specific dialects. Most of the time there are plenty of assemblers with different features and so on. But usually it's rarely enough. You need often to have C++ code on the side to generate, for example, cosine tables for demo effects, or like plenty of pre-compute data that you would need. And of course, you need to usually like some kind of make files to glue things together, to assemble, to link and generate program files or D64 image files that once built, you will be able to manually load it into the, for example, one Vice C64 emulator that is a popular emulator, or on a real machine. And then after you need to copy to the real machine. And I'm also alluding the fact that like, and the challenges that like of debugging. So that's why I developed the Retro C64. It's a modern SDK for the Commodore 64 development, straight from .NET. So it comes with a zero friction dev loop, which is going to auto-launch Vice, the Vice emulator, and doing live coding, and we'll see that later. I've developed also a Fluent assembler, ASM 6502, that I released earlier this year, which can manage labels, sections, data blocks, and helpers with source mapping back to C#. There is some basic integration, like where you can quickly prototype things, and several core helpers to allocate data into the 0 page, for example, or initiate all the interrupts for the raster line, or using sprite classes and things like that. There's, of course, like a seed tooling, which is going to help with loading seed files, which are music with the player integrated in it. And there is a relocator and player inside. And then we have like all the things to manage the format that are used by the Commodore 64, the program files that you can store on the disk, or the D64 image that you can use on your PC to transfer it to a real disk. And then last but not least, one of the really cool things that I wanted to have for this development experience was first-class VS Code debugging support with respective registers, memory, setting breakpoints, execution control, step in, step over, etc., etc., and viewing disassembly, memory, and all of that. And of course, supporting all the .NET platforms, all the OS with .NET 9 Plus, so it can work with .NET 10. So now let's experience a live demo. I hope that everything is going to work as planned. Here's my screen. I have here, like on the left, a basic program, which is very simple. You can see it here. And I can zoom in a little bit if you want up. And then after here, I have the command line where I can launch a command. And here I'm going to launch .NET Watch Run, which is going to run this program. It's just a console application. And what it's going to do is going to compile the project, build it, and deploy it to the Vice emulator. And here you can see that on the screen with the Vice 64 Commodore emulator, I have my program running straight into the emulator. And at the bottom, you can see that I have .NET Watch still running. So that means that I can edit while the emulator and the application is running to see in real time the changes that I'm going to make. So for example, if I change this, so I'm going to resize. If I change this here and I'm Command here and I Control S, it's going to recompile here. And here we go. We have the program that is automatically reloaded in the Vice simulator. So you can actually live program very easily from C# directly, and it's going to reflect on the screen on the emulator. So that's the first program, and like it's the most basic experience that you can get with Retro 64. But it's not the thing that I didn't create Retro 64 for this program. What I wanted to do is really to program in assembly language, because that's where you can really take advantage of a computer, and you really need to use assembly when you need to take advantage of it. So here we have a very simple program, a little bit more complicated because there are some special things in it. And I'm going to use .NET Watch again. And it's going to similarly open a new window. Things are not super exciting. It's a very small program in assembly, and assembly language can be very verbose. But what you can do is that you can command the code here. So it's recompiling, and you can see that I can change the border color almost immediately, and I see the change in screen. I can command this line, and then I'm back to the screen. For this, in assembly, I have implemented a soft reset of the machine so that you can see that I don't restart the machine entirely. I just restore some states, seed register, and so on, to be able to reboot my program more quickly. And of course, I can modify some properties here to create some effects. I know full effect. It's not really nice. And similarly, I can command things. So here, for example, I'm not going to do it on the border, or actually it's nicer to do it on the border. We can see the text. And that's all that simple, like live coding in assembly language from Visual Studio with the emulator. So now let's try something a little bit more like advanced. It's hello sprites. Let's look at what we can do with sprites. So if I run this program, it's going to show a few sprites on the screen. And it's 8 sprites here. And what is really cool is that the code is actually implemented. So where is it actually? Where is it? I missed it here. It's actually implemented with this code here, where I'm using actually Skia Sharp to draw the sprites directly in memory. And I forgot to copy this line, so I'm going to need to copy it from that place. Sorry for the misstep in the demo. But what I can do is that I can reprogram the sprite directly from C#, and it will change them on screen immediately. And all of this code is running like the Skia Sharp library that is used by .NET MAUI, for example. And you can like command code here and change things, and you have like this combination. or I could also decide to also combine with this, or maybe even command the middle and have a combination of this setup. And you can see that at the bottom, I'm storing the sprites in memory, and then after, of course, there is some code like to make it happen in assembly language, but it's quite straightforward. Now, I talked about the music, and of course, you can also program a music. So what I have in my project is here a music that is made by, this one is made by Linus Akesson. It's a beautiful little music. And if I run it here, same, we are going to hear some music in the screen. I think that you should hear it a little bit. I made the sound. Low. I could increase the sound, and you can hear it a little bit more, but I'm going to lower it after. And so let me lower it. What is very cool here is that we can load the seed file, relocate it in memory, instantiate the player, initialize it, and play it. It's that simple. And what is very cool with the integration of C# and all the things that we can do within C#, so we don't need a makefile, we don't need a C program file separate, is that I can take the data that is coming directly from the seed file and display it on the screen. So here I'm reading the 04, the name and the release date of this music, and I can put it straight on the screen. And lastly, it's something that I made specially for this event. I made a demo actually. So it's a very small demo. I'm not like a Commodore specialist, and so bear with me. Like it's just a small demo for this event. But so of course, what we can do here is that, oops, we can just have a clear screen. It's not going to be interesting, but it will give me time a little bit to show you a little bit the different parts. Okay, we have a white screen here. We could, I think, change it here. We could put the character 0, and it would recompile everything. Character A, it would put A. Okay, that's not really interesting. But the first part, it's not the first part of the demo, but just like to show you that we can change things. I've made a logo for the dotnet conf. The logo is at the bottom of this file. Actually, you can see it here if I dezoom, and you can see that like it's highlighted here. And it's just like a copy of a character in memory. I'm going to copy to the screen. And then I have sprites that you just saw before. Difference here is that I'm going to animate them. And what is very nice with this setup is that I can actually create all the sine and cosine tables directly from the code here, integrated in the same source code where I have all the assembly language that is moving these sprites on the screen. And then the full demo that I can launch here, where I have an additional small effect. Let me just stop. So this is a demo with all the parts. And I've just added a small effect, a typical demo effect in the demo, to show that we can really create some very cool stuff in assembly language. The code is including with all the data and all the setup to make it live, etc. is just like 600 lines of code. It's not that much actually. And yeah, it's super cool, right? So one of the biggest cool thing also that I wanted to show you today is the debugger. Because here we can set breakpoints. I'm in Visual Studio Code, and I can press F5, and the demo is paused. You can see it on the screen. Oops, no, that's the wrong screen, sorry. And here you can see that I'm in the Visual Studio Code debugger, and I can see the accumulator, the register, the CPU flags. I can even inspect the VIC registers, the zero page even, like I can see that, oh, the C player is taking these variables and all of that. I can step in. I can inspect the changes here of the registers. I can even go to the disassembly view. Where am I? It's the same code that I have here. And I have also access to the memory of the 64 that is running in the emulator here, directly straight from VS Code. I can play and go to there is also the data watch that is working, and I won't show it. But you can do everything here from VS Code. You can pause. It's going to pause at some place. You can continue, and it's going to work now. And that's it for the demo. So let's come back to the end of the slides. I have 4 minutes left. So the SDK is organized around 4 main packages. The main package that contains the app layer that manages the lifecycle of the build, .NET Watch, and the live sync with the emulator. There is a debugger that connects to the Vice emulator through the remote interface. There's a core package that contains all the core functionality that I said earlier, the basic, the assembler, the loader, packers, graphics, music, and all of that. We have the assembler, the 6502 and 10 assembler. There is even an emulator inside it. I developed an emulator, especially a CPU emulator, because for the seed relocation, I had to port the code from Linux Akeson to be able to relocate seed files to a different memory location. And finally, we have the Vice package that is able to connect to the Vice monitor that is running the emulate, that is running the C# program, the C64 program. Sorry. So I would like to zoom just on the debugger because I think that it was a really interesting challenge, and I learned a lot from it. So in particular, I discovered the debug adapter protocol, protocol that lets IDE to talk through the common interface without needing to know which one works internally. So when you create a Retro64 application, there is actually a debug adapter inside it. I lied earlier, like it's not a real debugger. The debugger is actually in the Vice emulator. And when VS Code connects to the Vice emulator, it uses the DAP to communicate with that adapter inside the Retro64. And the adapter then proxies all the calls to the Vice monitor and also enriches them with information only that the Retro64 runtime knows, like variable names or source mapping, so that the DAP protocol can feedback that to the VS Code. And of course, to make all of this work, I had to implement dozens of callback functions. It feels like a mountain of work at first, but it turned out to be totally manageable, actually, because in our case, we only have one thread. We have one frame in the call stack. So lots of things are actually much simpler than, let's say, creating a debugger for C#. And honestly, I found it very cool that adding full debugger support in C# to this project was ultimately very straightforward. So as I said, what's coming next? First, I need to add the fast loader. The assembly code has been ported, but it's actually not finished, so it's not completely finished yet. I need to add ZX0 depacker. I have created the packing system in C# entirely, but I need the depacker. It's a small amount of work, but it still needs to be done. The SDK doesn't support also multi-part demos yet. That's what the fast loader and the ZX0 depacker are going to enable. Documentation, and actually, since I create these slides, I have actually a surprise to share. So actually, I have some documentation. Graphics, because, for example, I just made the sprites for this demo, but I don't have anything related to bitmaps or converting from real images or making the process conversion easier with differing and things like that. And then a bunch of little tiny things. And of course, contributors are going to be super welcome in this project if you are interested. So thank you for watching. Here's the website. I can actually show you the website just a little bit here. You can connect with this address. There is like the front page. There is actually some documentation with getting started, what you need to install, the overview that we just saw before, a little bit more details about the assembler, some details about graphics, musics, helpers, all the names that are in the registers and so on, and some documentation about debugging. So that's super nice that I was able to finish that for this event. And of course, happy coding. Don't forget to maybe buy, if you have the chance to buy the Commodore 64 Ultimate that is going to be released like this month or next month. It will help to grow the community, and maybe you will be able to enjoy programming with Retro C64 in .NET, in C#. Probably most likely I haven't tried in F# and even in Visual Basic to program the Commodore 64. Thank you for watching.